Welcome to today's tutorial. Let's get started. Let's have a look at our agenda for today. Today we are looking at Retrofitting Legacy OCS, and this is part 2 following on from last week's video. Part 1 covered some important steps in terms of examining the I/O requirements and looking at your older ladder logic and reusing it. So make sure you go and look at part 1 if you haven't already. Today we are looking at retrofitting the early OCS graphical units. We'll start with a brief history of the graphical units and then we'll review the old hardware. We'll talk about some recommended replacement units and some of the modern hardware you can use instead of these original systems. We'll summarize the retrofit procedure, which is a similar procedure to last week. I'll also give you techniques for modifying your old graphics if you want to reuse them. We'll have demonstrations throughout, and as always, we'll finish with a Q&A session. Let's start with the history of the Graphics OCS. After the successful release of text-based OCS a few years later, Horner expanded into graphical-based units. One of the reasons we didn't start with graphical user interface on the OCS was because of the limitations of the microprocessors of the time. So when we did go into graphics in the early 2000s, we went with a dual microprocessor approach, where we had one processor dedicated to logic and a second one dedicated to the graphics. Then those two processors shared RAM for variables. So these were the first high-performance all-in-one controllers that had a graphical user interface. Around the same time, we released some other products that expanded the I/O capacities of the OCS. One of those products we released was called a Remote Control Station, or RCS. This was essentially an OCS without a screen, and these proved popular for both PLC control but also as a remote I/O block. The original OCS utilized SmartStack I/O stacked on the back of the OCS, and you were limited to 4 modules in total. With the RCS, you could expand beyond that limitation of 4 modules. We also introduced fiber optic bases, or FOX bases. These allowed SmartStack I/O to be stacked on these remote bases that were connected using fiber optics up to 10 meters away from the OCS. That gave the potential of having a total of 20 modules between what's stacked on the back and the remote I/O bases. So with some of these graphical OCS systems, the I/O count can be a bit larger, which we have to consider when we're doing our retrofits. Through the 2000s, we expanded from all metal type products to include plastic design. We also adapted the SmartStack I/O with a plastic chassis as well. Around this time, we also released SmartSticks, which was our first pure remote I/O solution, which is still a viable product today. We also expanded into color graphics, culminating with the QX series, which offered a variety of units from 6 inches up to 15 inches. We also released the RX371, which was a metal design for more rugged applications. Other than the SmartSticks, all these products are obsolete at this stage, so these are all systems that would apply to today's webinar. Now let's look at some of this older hardware. This is the OCS 250, which was the very first graphical OCS. It's made of metal and it was released around the year 2000. It supported up to 4 SmartStack modules on the back, though this one doesn't have any. It has 2 serial ports in addition to the CAN port, and it's also the first product that we sold that had more than one serial port. It had a monochrome display of 240 by 128 pixels. Here is the RCS, which is effectively an OCS without a screen. It's often also used as a remote I/O block, and it's also metal and can support up to 4 modules. For a true remote I/O solution for SmartStack, we offered this remote fiber base. This one here interconnects with Toslink plastic fiber. You can have up to 4 modules plugged in on it, and you can have up to 5 of these bases on a system. The maximum distance that any base could be away from the OCS was 10 meters. As the OCS became popular, we started with plastic designs. The first of these was the NX series. These were graphical in nature, and this is a small NX222 which has the same pixel display as the current XLE does. We also had a 240 by 128 version. It utilized SmartStack, but the plastic version of SmartStack with the same electronics but a new chassis. Then for removable media here we have Compact Flash, which is obviously a lot larger than what we're using today. We also released the QX series at the same time for customers that were looking for large colors touchscreens. These were available anywhere from 6 inches all the way up through 15 inches. Then we had a Horner designed backpack that went on the back to add the Smart Stack capability along with CAN and fiber. Of course, all these products are now obsolete. Now let's look at some modern replacements that you can use for some of these older systems. There's no one right answer here, but here are the factors that you would consider. You should ask yourself, what size is the screen you're replacing, and are the function keys used in this application, and if they were, do you want to maintain that? You also need to ask, what is the I/O requirement? But again, if you're not really sure, for smaller screen applications, the EXL6 and the EXLW are good options. For larger units, a 10 or a 15 are good options. Another factor you should consider is the cutout. In the early 2000s, 5.7 inches was the most popular size for user interfaces, whether they had built-in PLCs like an OCS or whether they were just separate user interfaces. For our newer products, the EXL6 and the EXLW have the same exact cutout, so they are often a good choice, especially if you're replacing a 5.7 inch unit. Now let's look at replacing the I/O. Usually, you can find a built-in I/O option with one of today's OCS models that will take care of your requirements. However, if you have extra I/O that was distributed on FOX or an RCS, you need to take a look at our expansion I/O such as SmartRail, SmartBlock, etc. If you have an application that had a lot of high-speed counting beyond the 4 that are built into most OCS models, then you need to add some external high-speed counting capability beyond what's built in. Here you could use an RCC 6512, which we consider a high-speed counter coprocessor type module, or even an XLEE, which can also be used as a remote I/O block. Now let's look at the retrofit procedure for retrofitting these graphical units to a newer, more modern product. These 6 steps have not changed from what we covered last week, but there are some differences that we need to highlight. We'll start with acquiring the program. The first question you need to ask yourself is there a Cscape or CSP file readily available, and do you have access to it? If you don't have access to that file, then you may need to upload it from the OCS. If you're uploading a program from a graphical unit, you'll likely want to start with Cscape 8.8, and note that's a different version from the version we suggested last week for text-based OCS. If it was developed using a newer version of Cscape, then Cscape will tell you that and you can try a newer version. From a connectivity standpoint, if you're talking about one of the units that has a 9-pin serial port, then the advice we gave you last week about your programming connections is still valid. If you have a unit that has an RJ45 serial port, then you can use our standard Horner cable kit for uploading. Once you've uploaded using an older version of Cscape, of course you should immediately save that program. And then you can use that original version of Cscape to analyze things like the I/O usage, the ladder logic, etc. An important point is that you don't need to replace all the I/O on the previous system, you only need to replace the I/O that's actually being used. For this, there's a feature in Cscape called element usage that you can use, which will tell you what real-world I/O is actually being used on the system. For more details on that, see last week's webinar. Next, let's talk about where most of the differences are in the retrofit procedure. Since we are talking about Graphics OCS, those differences are mainly on the user interface side of things, because the original text-based units had text-based user interface screens that could not be reused. The first thing you need to ask yourself is, should I even reuse these graphics from this older project? There are some scenarios where you may decide you want to start over again. For example, if you're taking a small monochrome user interface unit and replacing it with a large color touchscreen version. In that case, it may be more suitable to make a new user interface. In other scenarios, for example, when upgrading a color model to another model with a similar screen size, reusing the original screens may save a lot of time. With anything graphics related, generally you can put in as much effort into the graphics as you want, depending on what time you have. Now we'll talk about 2 different scenarios for reusing your graphics from an old retrofit system to a modern controller. The first scenario is when you're changing from an older controller that had a lower resolution screen to a newer controller with a higher resolution screen. In my case, that is a ruggedized RX 371 with a 320 by 240 VGA display, and will replace it with a EXL6, which is also a 5.7 inch product, but with a 640 by 480 screen resolution. This is our procedure for changing to a higher resolution screen. First, we'll open up a copy of that Seascape program in a new version of Seascape, such as 9.9. The next version is to go to the hardware configuration and change from our RX 371 model to our new model, which in my case is an EXL6. Next, we'll go into the graphics and use the Fill All Screens option. That allows you to take all the screens in a single step that were of a lower resolution and automatically stretch them to a higher resolution. Now let's demonstrate that in Seascape. I'll start with my RX 371 program that I acquired. I opened it in Seascape 9.9. Let's do the hardware change first. I'll go to the hardware configuration, and I'm in the QX series now, so I have to change that over to the XL series and then to an EXL6. Then I need to pick the I/O model that best fits my application. Let's say the Model 4 is the one I want. Now I've changed to the new OCS controller. Next, I need to adjust my graphics, so I'll go to the graphics editor. You'll notice the screen information from the legacy project all fits in the upper left hand corner because the RX 371 had a resolution that was 1/4 of the resolution of the EXL6. Now I'll take advantage of that Fill All Screens feature. I'll go under the Screens menu and select Fill All Screens, and then Seascape will automatically go through and stretch all the screens. That's worked, but there's some adjustments that we're going to want to make. For example, we want to go through and adjust things like the font sizes. So here, I'll make the title bigger. Then let's increase the font size for this data field, and then I'll go and make that one a bit smaller. Our text table here is small, so I'll make that font bigger. Now, even though that's a lot bigger than it was, we need to stretch this widthwise so we can fit all 13 characters in for this data field. I'll make this data field a bit bigger. Again, here I'm just going into the legend and increasing the font size. And then, after all that, I'll make this size larger as well. I'll put that up to 30. So that mainly was just changing the font sizes. I didn't have to modify any of these data fields, and they are all still tied. On this screen it's the same. For example, I can move things a little bit to the center, or adjust some of the sizes of the fonts, etc. Now let's look at our next scenario, which is where we're going down in resolution from a higher resolution older unit to a lower resolution newer unit. You may ask, why would we want to do that? Well, there is a few potential reasons. In the 2000s, there was actually a lot more screen sizes that were common, whereas today, from a popularity standpoint, the most popular sizes for the most part are 7, 10 and 15 inches. That's because the industrial market is using the same glass that's popular in the consumer market, so there's less sizes that are available to the industrial market. For example, the 8.4 inch QX was a very popular product and it had an 800 by 600 resolution. From a size standpoint, the best replacement for that is probably an XL7. However, the XL7 has an 800 by 480 resolution. So here we need to go from a higher resolution to a lower resolution. For this, the steps are a bit different. We'll start out the same with a copy of our Seascape program that we acquired through an upload or from an archive. Then we open that in a newer version of Seascape. Next, however, we have to go through and edit all the graphics and shrink them down to fit within an available space for the new display. We need to do that before we change our hardware configuration over to the new unit. Otherwise, the extra graphics will be cut off if we were to do the configuration first. Then once we're done with all the graphic manipulation, we'll go into the hardware configuration and change our model over to the newer unit, which in this example is an XL7. Now let's demonstrate that in Seascape. Now I'll open up my other project, which was based on a QX451. Since we're going from a higher resolution to lower resolution, we have to manipulate our graphics first and shrink those down to fit within the space allowable in the new XL7. Here are my screens. This is a screen with 800 by 600 resolution. We need to shrink that to fit an 800 by 480 screen. The most convenient way to do that is to group all of the legacy graphics into a single group. Then I'll hit Ctrl A to select all. Then I'll right click and hit Group to group everything together. Next, to make it easy for me to understand where the limitations are with my new display, I like to draw a box. So I'll pull up a rectangle here and put it on the screen, and then double click on it. I'll make it easier to see by changing the color, and I'll make it thicker. Then I'll stretch it out until it's exactly 800 by 480 pixels. And here I'm looking in the lower right hand corner, and Cscape will tell me when I get to 480 pixels. Now I have a red box showing me where the 800 by 480 borders are. Now I'll click on my legacy graphics that are all grouped together. Then I'll grab the corner and stretch it to fit the new confines until I'm happy. Next, I'll do one more screen for you. I'll copy this red box and I'll go to the next screen. This screen is a bit more complicated. Anytime you have legacy screens that have bitmaps on them and you're going to be stretching and changing the size, you should consider making sure that all the bitmap graphics are configured to scale, so that if you change its size it will scale, because remember, one of the options we have with bitmaps is just to show it in its native resolution and not to scale it. So I'll double click on this graphic object here, which is showing up as a text object. So it's buried within this, and I'll hit the tab button until the graphical object is displayed. So here we are, and now I'll send that to the back. Now I have my bitmap object and I'll select Scale to Fit. I'll send it to the back again so that the other objects in the front will be where they need to be. This is a bitmap object here as well. So I'll double click here and make sure that says Scale to Fit as well. Now I'll select all and then I'll group it. Then I'll copy my box that's showing my borders and I'll paste it in. Now I want to grab this corner here and scale everything. There's a few things here that I should probably fix. I think this pump would look better if it was in its original aspect ratio, so I'll get rid of the Scale to Fit there. This text is obviously too large, so let's change that down to a 10-point font size. Then I'll change this data field down one notch. So here we're reusing the graphics, but it translates well from the old screen to the new screen. And when I'm done manipulating my screens, I'll get rid of these red boxes since they're just there as a guide. So I'll delete that, and then I'll go to my other screen and I'll delete that box as well. And now I'll close the graphics editor and go back into the hardware configuration, and now I can change over to my XL7. I'll go to the XL Series and then XL7 and select the model that I want to use. I'll hit OK, and when I go back and look at my screens that I just manipulated, you'll see that they fit very nicely on the new 800 by 480 screen of the XL7. So that concludes our demonstration for today. Thank you for joining us for today's tutorial, and the Q&A session will begin shortly.